problem. So first of all, we are going to break this integral in two parts. We can write this as 1 plus cos square x 2x upon 1 plus cos square x dx, and this can be written as minus pi to pi 2x sin x 1 plus cos square x dx. So this integration of the form minus a to a fx dx. So first of all, we check that the given integrand is even or odd. So we can look here that this function 2x upon 1 plus cos square x is an odd function. Why? Since if we take phi x equals to 2x upon 1 plus cos square x, then phi minus x equals to, this becomes 2 minus x, and this is 1 plus cos square minus x, and cos of minus x is cos x, so this becomes minus 2x plus 1 plus cos square x. Why? Since cos of minus x equals to cos x. So this integration, this function becomes minus of phi x. So phi x is an odd function, Therefore the integration minus pi to pi 2x 1 plus 2x upon 1 plus cos square x dx is 0. Again, also we know that we can check again. We have second part of the integration is this term becomes 0, and so our integration becomes I equals to 2x minus pi to pi 2x sin x upon 1 plus cos square x dx. Again, we can check here that this function is an even function, since if we take fx equals to 2x sin x upon 1 plus cos square x, then f of minus x equals to 2 of minus x, this is sine of minus x, and this is 1 plus cos square of minus x, and this function becomes, this is, we know that this is minus 2x, and sine of minus x is minus sine x, so minus sine x, and this is 1 plus cos square x, since we know that cos of minus x is, since cos of minus x equals to cos x, and sine of minus x is equals to minus sine x. So this becomes, this is the value of this function becomes, after multiplying, this becomes 2x sin x upon 1 plus cos square x, and this is fx. So we have seen here that for every x, f of minus x equals to fx for all x in a real number. So therefore this function fx equals to 2x upon 1 plus cos square x is an even function, So therefore, by rule of definite integration, minus pi to pi, I equals to minus pi to pi 2x sin x upon 1 plus cos square x dx can be written as 2 times of 0 to pi 2x sin x 1 plus cos square x dx. Again we can look here that we are going to use the property that a to b fx dx is equals to a to b f of a plus b minus x dx. So using this definite integration of property, this property of definite integration, we can write this integral as, this can be written as 2 0 to pi, this is 2 into 2, this becomes, we can write it here as 4, this 2 and 2 becomes 4, and this is, at we replace x by pi 0 plus pi plus 0 minus x, we replace x by pi minus x. So at the place of x we can write pi minus x, and this is sine of pi minus x, and this is upon 1 plus cos of pi minus x square again, and this is dx. So again, using this value, our I becomes 4 times 0 to pi minus x, and this can be written as sin pi minus x is sin x, and cos of a square, cos of minus cos of x whole square dx, and this can be written as, this becomes 4 0 to pi minus x sin x, pi minus x sin x, and this is 1 plus cos square x dx. Again we have, so our I is, we have given I is, we have found that I equals to 4 times 0 to pi x sin x 1 plus cos square x dx, and again we have I is, again we have, using this property, this property, we have found that the value of, another value of I is 4 times 0 to pi minus x sin x dx. So we can write it as 4 times of 0 to pi minus x sin x 1 plus cos square x dx. Adding these two integration, adding these two, so this I plus I, and this becomes 4 times 0 to pi, this is pi minus x sin x plus x sin x, and this is 1 plus x square x dx. Writing it precisely, we can add two definite integration in a single definite integration. This becomes 2i, and this is 4 0 to pi, and this x sin x gets out to be cancelled, and this is pi sin x upon 1 plus cos square x dx. Again we can write this integration problem, this integration can be written as, this 2 gets out to be cancelled, and this becomes 0 to pi, and this is 2 pi, and this is sin x upon 1 plus cos square x. Again put cos x equals to t, we can write it, sorry, we have dx, so we can take cos x equals to t, and this is, so minus sin x dx equals to dt, and our integration problem at limit of the integration becomes, at x equals to 0, t equals to cos of 0 equals to 1, and at x equals to pi, t equals to cos of pi, and we know that cos of pi is minus 1, so our integration becomes I 2 pi, and this is 1 to minus 1 minus dt upon 1 plus t square. Again we can change the limit of integration by changing the sign of definite integration, so we can write it as 2 pi minus 1 to 1 dt upon 1 plus t square. Again this is 1 plus t square is even function, so we can use again another property, though, since this can be written as 4 pi 0 to 1 dt upon 1 square plus t square, since 1 square can be written as 1. So, and this is the formula, this is the standard formula, we can use the standard formula, dx upon x square plus a square equals to 1 upon a tan inverse x upon a. So using this formula we can write it here, that this becomes, using this formula, this becomes dx upon integration of 1 upon x square plus a square equals to 1 upon a tan inverse of 1 upon a tan inverse x upon a. So using this formula, here a is 1 and at the place of x is here t, so this becomes 4 pi tan inverse t, and 1 upon 1 is 1, so this is 0 to 1. Putting the value of I equals to 4 pi, this is tan inverse 1 minus tan inverse 0, and this is 4 pi, and this is pi by 4 minus 0, and 4 gets out to be cancelled, and this becomes 4 gets out to be cancelled, and this pi into pi, and this is pi square. So our value of integration is pi square. This is the answer of the given problem. Thus we have solved our given problem. So this is the answer.